And if you've just joined us, my name's Kyle Houchins. I'm a tech and a trainer for McNeil, the folks who bring you Rhino. And I also run a consultancy called The Outside Digital Art and Design. That's my webpage right there. You're more than welcome to check it out. And these sessions we like to do about once a month. And we like to just have it be a really informal, casual conversation between you and I. And I like to show bags of tricks. I like to show new features. I like to show random thoughts, bad jokes, good modeling, bad modeling, fast modeling, sloppy modeling, whatever we need to do to get to the end of the show. And if you've seen other webinars from other software companies, you're not going to see that here, because the entire idea behind this is getting started, right? And so the reason that I do it in this format is because I want to put myself in the same position that you're in when somebody walks into your office and hands you a sketch or gives you a task or gives you a job and says, I need this. And you say, in your head, you say, I have no idea how to do that, so I have to figure out how to do this. But outwards, you know, of course, as a good little consultant, you're going to sit there and say, sure, we'll get that to you in no time. And then you go and have a panic attack in the corner and figure it out later. The cycle of project when I get something into my consultancy is somebody calls me on the phone and they give me a job, and I say, absolutely, we can do that. That's absolutely fantastic. And then I hang up the phone and then I go sit in the corner and hug my knees and rock for about 15 or 20 minutes while I try and figure out how I'm actually how my butt's gonna cash the check that my mouth just wrote. So, so that's consultant life. But what I want to talk to you about today is a thing that is becoming more and more prevalent, which is reverse engineering, and that's our destination. The path to get there, we're going to cover two new really awesome features in Rhino 7, which is subdivision surfaces, some really cool features within subdivision surfaces, and then some quad remeshing and things like that. So in the past, just to give you a little bit of historical context, reverse engineering is the process of taking scan data like you see on my screen right here. This is an unorganized triangle scan, and it's actually a pretty organized triangle scan, all things considered. But for this demo, we're going to call this an unorganized scan. So this is a model that was given to us by Heath, who's joined us today, and thank you very much, Heath, for allowing us to use this. This is going to be a cool demo. I've been pretty excited about this. So, are we losing audio? Do you guys have audio? Anybody have audio? See me, hear me? Hit the chat and let me know if you can see me and hear me. Okay, cool. So Heath let us use this model, and basically what the project here was, he scanned a foot last, right? This is a footwear foot last, and let's shade this so you can see it. And what he does is he's a custom boot maker, and so he scans this last, and then he scans the feet. Not seeing any video. Does everybody see video? It says I'm seeing video. Everybody else sees video? Yes, yes, no, yes. Everybody else sees video? A few people don't, huh? Okay. Let me stop showing the screen and start it again, and let's just see if that fixes it. Should see no video now. Should be back. Do we see video now? Okay. All right, we're good. All right, so what Heath does is he has this foot last, which is a hard sculpted piece, and he scans this, and then he has customers come in and he scans their feet, and then he has to make the last custom to the person's foot. So he needs to modify this last to match the foot scan, and then CNC the foot scan or print the last and end up with something that he can then build over to make what I can only imagine are incredibly awesome custom boots. So what we're going to assume is that we've already gotten through the scan part, right? I don't want to have to cover the scan part because that's a whole nother issue. But if you're a jeweler, if you're a bootmaker, if you're a product designer, the scanning stuff has come down pretty dramatically. In fact, Next Engine makes a scanner, I think it's under like $3,000, that actually is really pretty decent. And there's a bunch of other stuff out there that you can use in order to get scans. This also works, like let's say for instance you go to Turbo Squid and you get a Studio Max model, right? And it's polygons and you can't do anything with it in Rhino. We've all kind of been there, right? You should feasibly be able to, and there's a big leap in here where between a Turbo Squid model and where we are right now, because the Turbo Squid models typically are not made for production. They're typically not made watertight, which means that there's going to be some work to be done in order to get them to be to this position, which is a watertight model. So let me just caveat that and say, if you guys are like running to Turbo Squid right now and downloading, Laura Croft models and you want to make SubD models out of them, slow your roll. There's going to be a little bit of work to do in there in order to get there. And we'll talk just a little bit about that. But let's look at what we've got here. And if I back out a little bit, I can see, first of all, that the scan is located kind of in weird XYZ space. And so let's put it where we want it to be. I'm going to just move it up here to the origin. And then the next thing I want to determine is, first of all, I want to verify a few things. I'm going to go to Tools, Options. I want to go to Units, and I want to make sure that I'm working in the units that I want to work. Because I'm a dumb American, we still work in inches here, and so I'm working in inches. Everybody in Europe is groaning. You are fully validated in being able to do that, but I'm working in inches. So I need to figure out exactly how big this thing is to make sure that I'm working on the thing that is the right size. And so I'm just going to go up to dimensions. I'm going to snap to a vertex here because I have my vertex snap is checked down here. And then I'm going to snap down here. And this is 11.5 inches, which is about what I wanted, right? It's not super critical because we're going to make some modifications to it, but I want to make sure that this isn't like 17 feet, right? Or it's 3/4 of an inch long. I want to make sure that I'm at least working at approximately the right scale. So I can get rid of this now. And let's take a look. Let's do a few things to just verify before we get started. I'm going to run the command cell open mesh. And right now, nothing lights up. See how it says no objects added to the selection? That means that for the most part, this is considered we have a pretty decent assurance that this is a closed watertight part. We can run one more thing. We can run check, and check is going to give us a bunch of information about this. Now, the mesh has 8 non-manifold edges. It has 6 duplicate faces. It has 45 pairs of faces that intersect each other. This is probably something I want to take a peek at. This information here is all of it's good except for this line right here. Mesh has 2 disjoint pieces. Okay, 2 disjoint pieces means that there's 2 pieces of mesh that are hanging out in this thing that are not connected to anything else. So let's see if we can figure out where they are. And if I start zooming around this thing and look, it all looks pretty clean in here. I don't see anything hanging around there. And when I get up to here, this is what I'm looking at. See this right here? And it's going to light up a bunch of stuff. But these are the disjoint pieces right here. See this? That's one of the edges. This is one of the edges. So the way to get rid of that, the easiest way to get rid of that is I'm going to just explode the mesh. Now, look at your command line when you do this. See how it says exploded a polygon mesh into 4 meshes? That's great. If you run explode and it says, whoa, this is going to explode into 25,000 different meshes, you might want to think about doing it a different way. And the different way to do it is just to shift, control, click on each one of these polygons to get rid of them. But in this case, it worked out well where I can actually select this piece and delete it, and I can select this piece and delete it. This is just a little piece of scanner chatter, and it's just hanging out in space there, and so we want to get rid of it. Now, in this case, we can see that we now have two pieces of mesh here, right? I've got this mesh up here, and I've got this mesh down here. So there's two pieces of mesh there. So I'm going to just grab those and I'm going to join them again. Two meshes joined into one closed mesh. That is a good sign. That's what we want. All right. Now, say for instance, we had a situation where there was, and I'm shift control dragging to select these polygons. Let's say we had a hole in this thing. Okay. Now when I run check, it's going to say 23 naked edges. This is what you want to pay attention to. Okay. Naked edges are the death of successful STL prints. If you want to send this to a printer, the print is going to fail because this is not a watertight part. All right. The rest of this stuff is all good. See, this does not have any degenerates, end-gons, short edges, manifold, non-manifold, duplicate, faces, self-intersecting disjoint, or unused vertices. This is as good as it gets, right? This is exactly what we want. But we do have this hole down here, so let's take a look and see how we fix that. And if I pick this and I go to my Show Edges tool, which lives way down here, I can see that the naked edges, we don't want to use all edges because it's going to light up everything, but naked edges lights up pink. And if I shade this, you can see exactly where the hole is. Now, the other thing is, see how this hole goes over, trying to get a good angle. See how this hole wraps around in this kind of banana shape here? That's a difficult thing sometimes for hole fillers to deal with. And so what we're going to do is help it out a little bit and break this up into a couple of more reasonable shapes. Okay, so I'm going to go to Mesh, Repair Tools, Patch Single Face, and I'm going to pick this edge here, and let's just pick this edge over here, and I'm going to run a patch across that. So I've broken the one hole up into two holes now. Then I can use Fill Mesh Hole, because I want to do it one at a time. There's two commands. There's Fill Mesh Hole and Fill Mesh Holes, which fills all of them. I want to use the Fill Mesh Hole because I want to do this one, run it again, and do this one. So now our mesh is patched back up. And that's a really powerful way of dealing with meshes, in the fact that you've got, you know, a hole that wraps over a corner. This happens a lot like on square objects, like something that's a cube and the corner's knocked off. And so what you do is you rebuild the corner first, the edge of the corner first with patch single face. You do this one here first, and then you go and patch the faces of the parts that are missing. So now I'm going to use Cell Open Mesh command. Nothing lights up, which means that this is now a closed part and we're good to go. But this doesnent really do me any good, right? So if I wanted to try and reverse engineer this in the past, I would have to use something like GeoMagick. I'd have to use something like Rhino Reverse, or something like that, and manually lay out patches and all that kind of stuff. Who has time for that nonsense? Not me. Especially not with the type of clients that I deal with, which are mostly like toy industry and entertainment companies and things like that. So what I'm going to do is I'm going to quad remesh this thing. Right now, these triangle meshes don't do me any good. However, I could print this, right? But if we look at it closely, you can see that this actually has kind of a chossy surface on it, right? It's not very, see how this is all janked up around the edges? We don't want to deal with that, right? So let's see if we can get a better version of this and ultimately end up with something in NURBS that we can mess with, which is really kind of cool. So let's pick this. Let's run the quad remesh command. This is a new command. If anybody's used ZBrush, this was written by the same guy who did Dynamesh and ZRemesher, which is pretty awesome. And we've got some settings in here. Let's go with a target quad count. Let's start off with like 2000, and I'm going to put my adaptive size at 50. Now, the higher this adaptive size is, now this target quad count is exactly what it says. It's a target. If you put 2000 here, you're not necessarily going to get 2000. It's just going to aim for that. Okay, so this is a very ish number here. The adaptive size, think of this as a detail slider. If you go to 100, that's all the detail. If you go to 0, you're letting the tool, pretty much take its pants off and run through the streets of New York. And it'll do anything that it wants. And so let's play with this at the first. Let's start with a medium detail, something like 2000, and let's start with an adaptive size of 50. And before we do that, let's take a look at some other things in here. There's a thing in here called guide curves. If I run this as it sits and just let it go, you'll see that it goes pretty quickly, and it ends up with a really pretty decent flow, right? That's not bad. In fact, that's probably can't improve that too terribly much. But let's take this and let's stick it on the side for a second. I'm going to hide it for now. Guide curves allow us to actually design how the polygons flow on the surface of the model. And if you've used ZBrush or some other programs, you'll recognize this. Topo Gun, I think, has this ability, and other programs like that. So I'm going to draw some guide curves through here. I'm going to project these onto the model. I'm going to get rid of these. I'm going to change these to red just so we can see them. By the way, these sessions are always considered interactive. So if you have questions or I blow through something that you don't understand or you want me to repeat it or explain it a different way, just hit the chat and say, whoa, do it again. So I'm going to change these to red so we can see them. And then let's run Quadremesh again. And chances are, if I select these guide curves and say, okay, we're going to get a pretty similar result to what we had because it actually did a really good job last time. So let's compare the two. And in this case, you can see that, see this star point right here? This one? See how it's changed locations here with the guide curves? So the flow is just a little bit different. See how this kind of wraps up here, but it comes down here? The rest of it looks pretty darn good. But the cool thing about this is you could take this and dump it into ZBrush and sculpt on it. You could take it into, whatever, any, 3D coat. You could do freeform. You could do whatever you want with this because this Quadremesh is gonna behave itself very nicely. So let's take these two. Let's say that this is the one that we're happy with. I'm going to just delete this one. I'm going to stick this one over here for the time being. And then let's run it one more time, but let's play with some settings. So let's change our target quad count to something really low, like 100. And then let's change our adaptive size to like 10. Okay. So what we've done is we've released the hounds and allowed them to run free, right? Because we've removed a lot of the restriction on the adaptive size. And then we've lowered the quad count really, really low. And I am going to go ahead and select guide curves. I have a hotkey for selecting guide curves if you wondered how I did that. And let's go ahead and run it. And you'll see that we're going to get a much different result. Now, the thing that I want you to notice is, first of all, it lost this up here, right? See how it just lost, it just blew that to pieces. So we may need to go up a little bit. And let's try it again. Maybe I want to make sure that my guide curves actually did get selected. So I'm going to pick them one at a time this time. Let's try it again. Let's see if it did any better. Nope, it still broke that. So let's call this unsuccessful. And let's go up just a little bit. And we don't have to go crazy. Maybe we go 150. Maybe that's what we get. Select the guide curves. The other thing that I didn't do is, let's try this once. Like I said, I make these up as I go along. Let's take the guide curves. Because this is projected onto a mesh, see how the guide curves are individual segments? Let's rebuild these and see if that makes any difference. Let's rebuild this to that. And these are going to be degree 3 curves now, so they're going to get rid of those facets. Let's see if that helps anything. All right, let's go 150. Although I guess if we were going to be scientific about it, we should look and see whether the rebuilt guide curves have any effect on the 100 quads, but if you don't like it, you can do your own webinar. All right, let's run this out here and say, okay, so it still kind of doesn't have enough to really get what we want. So let's bump it up just a little bit. We want to be able to capture the detail, but we want like enough information that we can work with. So there's a little bit of iteration in making sure that you get what you want, but a lot less iteration than it used to be. All right. See how that gives us a much better result? See how this area in here is good. Now, why would I want a lower detail model as opposed to a higher detail model? And the answer to that comes from our next step, which is converting this mesh into a SubD object. And if you haven't messed with version 7, SubDs are T-splines used to be the SubD plugin for Rhino, which actually, if you guys remember, I used to be the demo guy for T-splines. So SubDs is it's a hybrid modeler. It's kind of half mesh, half NURBS. It somewhere kind of lives in the middle. And what it allows you to do is to use a control cage to interpolate a smooth model. Now, let's take a look at where we are with this model. And if I lay this on top of here, you can see that this 250 quad model really pretty closely captures our detail here, right? That, as far as size goes, now we could argue and say, well, you know, it's not super accurate down in here, and you know, worst modeler ever. But the thing that we can do is, and then if we compare it, if we compare it to this one is much closer for obvious reasons because there's a lot more detail in here. But when you're talking about SubDs, the goal for SubDs is to have the lightest model you can have with the most amount of detail. So there's a really fine balance in there, right? So I would say that this model is too detailed for what we're trying to do. And the reason for that is if I take both of these and I run the to_subd command, I'm not going to use creases. I'm not going to delete the inputs. I'm just going to run them. And we can see, if I move these meshes over, I now have a SubD model. See how this one's smooth where this is faceted? And this one is smooth. Even though this one looks smooth, if we zoom in, it actually is faceted. See that? Facets in here. Whereas this one is now completely smooth. So what SubDs does is it uses this mesh as a control point cage. So what it does, if I turn the points on here, it actually draws a curve through each one of these points. And the parallel for that is in curves. So if I place a point here, 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 and here, and I turn the points on, this is the control cage, the little dotted lines. So the connection between SubD, between a quad mesh and a SubD, the control cage on a curve, right, is the same thing, same relationship of the quad mesh to the SubD. So the quad mesh is the little dotted lines and the points. The SubD is the curve, right? So the two have a relationship similar to points and curves. Does that make sense? I don't see anybody running for the door yet, so I think I've still got you. So So what we've done now is we've gone from an unorganized mesh to an organized mesh to a SubD part. Now, why is that important? Let's hide everything but this. New curve, new command in version 7, actually it might even be in 6, isolate. If you pick a part and run isolate, it hides everything except what you picked. Now, if I turn points on, look what happens. Look at the control cage. This is the original Quadremesh. Now, the cool thing about this is these points, if I pick these points and I move them, look what happens. See how nice and smooth that is? Now, to go back to my original question of why we would want less detail instead of more, let's compare these two. If I turn the points on for this, look at how many more points I have to deal with. We know from good curve creation that if I want a nice smooth curve, I do this, right? Now I can make the same curve with a lot of points, but look at how not smooth it is, right? So fewer points equals smoother curves. More points equals more opportunity for inflection. So the fewer points you have, the less inflections you're going to have in your part. So what that means is when you're talking about SubDs, you actually want fewer points to have smoother parts as opposed to more points. It's a little counterintuitive. So Andreas, architecture features, there actually is a lot of SubD application for architecture features. If you wanted to do some crazy Frank Gehry stuff, this would be applicable. So imagine just putting a door in the middle of this and a couple of windows and you've got a shoe-shaped skyscraper. I'm stretching, but we did have a lot of people at T-splines that use T-splines for architecture. So I'm going to say for this particular purpose, this is probably going to be no good. So I'm going to hide it. Now, in Heath's business, he's got this scan now, which is fantastic, right? But he needs to make modifications, so he's going to have a second scan in here of the user's of the owner's foot, and he needs to modify the last in order to match the foot. Well, let's say there's a couple common areas of modification. Let's say the toe, so I'm going to make a selection through the toe, and I'm going to bring up a tool called named selections, and this is new for V7 as well. And I'm going to save that selection, and I'm going to call this toe. Then I'm going to pick, let's see, I'm going to use the lasso selection. I'm going to pick the instep, or for lack of a better term, for lack of a better term, I'm going to call this a I'm going to call this the bunion area or whatever. I know that's not the right. Heath is, I'm sure, grinding his teeth hearing me say this, but. And then let's do another selection out here. We'll call this the pinky toe. And then let's go to the right-hand side. And we'll call this the instep. So what we did is we just built a little rig, right? And so I can save this. Elaine, there's yes, there are the entire series of getting started videos are on our YouTube channel. If you go to YouTube and just search Rhinoceros 3D, all of these videos get posted there, as well as our Vimeo page, which is vimeo.com/Rhino3D. Sure. Stick around though. Even if I'm losing you a little bit right now, this is information that will it'll sink in. All right, so so now I've got my last is set up, right? This is my master model. So when my client comes in and scans, and let's say they have a bigger toe box, they need a bigger toe box. If I double click this, look what happens. This lights up. I can then just scale this toe box a little wider. Okay. And I'm going to make gross edits for right now, and then we'll clean them up later. And then they don't quite fit over here, so I'm going to drag this out and make this a little wider. And then the pinky toe area, this is good down here, but this isn't. So I'm going to rotate from here, and I'm going to just pull this out. See how this is all happening smoothly? And then let's go, and then let's update the instep. And let's say they've got a weird instep thing going on here. So I'm going to pull this up and make kind of a gross edit. So I know that it's going to fit. And then I'm going to come back into this, and I'm just really simply clean this up so that it has a smooth transition. And maybe I need to move this forward and sharpen that a little bit. The thing about SubDs, and let's say they've got a weird heel shape, I can even pull this out to make a perfect heel cup so that it doesn't pull their socks down when they walk. I can do the arch, the instep, anything else, okay? So this, now I've got a completely custom last that fits my customer's foot. And that's great. And at any time, I can go back in and edit any of these things because these selection points are saved, okay? Now that this is saved, and I would then do file save as, and I would say this is like, you know, John Ferguson's boot, right? Save that off. I would keep my original unedited. So anytime I opened my original last, I would save this off as a save as, so that I've got my original with my selection sets saved. And then that way, when another customer, when, you know, Bob Johnson comes in, or, you know, Stephanie Murphy comes in, I can do a new file for each one of those without messing up my original file. Okay. Now, SubDs are great, but they're kind of a nothing part, right? We can render them, we can do all that sorts of that stuff. You know, if I go to ray trace mode, they will render and all that kind of stuff. But when it comes to production stuff, SubDs don't really buy us anything. So what we're going to use next is the NURBS command. If anybody's done any reverse engineering in the past, this is a lot easier. All right. So now I've got two models on top of each other. I've got a poly surface, so there's my poly surface. So this is still my SubD. This is a NURBS poly surface. So now I can do things like this. Wire cut. And I've got a solid part that I could then send to a CNC machine and machine it or do anything like that. Now, but wait, it gets better. SubDs, let's keep this and this. SubDs are offsetable, which means I can take my SubD, offset SubD, I can flip it to the inside. Let's offset it by 0.15 and go boop. Now, the beautiful thing about SubDs is if there is any mesh self-intersection, it is super, super easy to get rid of it. And in this case, there isn't. It looks good. But let's say for instance, and if I hit the tab key, I can convert it back to its control mesh setting. Tab is the toggle from smooth. So that's the control cage, that's the smooth interpolated model. Let's say for some reason this actually did this. Okay, this is a bad thing. We don't want this to happen. But let's say that it did. and we look at the model and we can see that there's this weird pinch going on here, right? And it's hard to determine what's going on in the smooth model, but if I hit tab, I can see, oh my God, look at that. So in the mesh model, or in the control cage, if I hit shift control click and turn on one of the points, I can simply just line this back up. I can clean this up super easily. Straighten all this back out. Look at my control cage and say, that line is following nicely. This line is following nicely. Everything is tracking nice and smooth. We're happy with the way everything's going. I hit tab, and our weird little thing is gone. Catherine asks, what if you needed to make the original design in a size 7 in size instead of an 11? Then what I would probably do is I would scale the original mesh, the original scan, this one, to a size 7 scan, and then go through the process again. Or I could take the SubD and scale it and then push it and smush it around in order to get the size of the 7. That's the one thing about this is just taffy, right? If I turn the points on this, I can take this entire thing and squish it like that, and it deforms so nicely and so smoothly. So it's really easy, and that's why we don't do this model, right? This model, see how many points there are? There's no way we'd get that many points to modify smoothly. There's just too much stuff to keep track of. Whereas this one is really pretty easy to manage. So let's do that for a second. Let me copy it. Let me copy this over here. And let's say for instance, and I'll just draw something random here. Let's say our customer had a foot that looked like this, okay? Let's say that was our customer's foot. I feel bad for this customer, but let's just say that that's the deal, all right? And we make custom boots, so they're happy to be here. I turn on my points, and I just start modifying. I just grab this stuff, and I just start pulling. And I just start pulling. And I can do really gross edits because I can always go back and refine, because it's just marshmallow fluff. I can just grab this and just squish it around and do whatever I want. Super easy. It's so fast. And because all of the deformations are smooth, I'm hacking this together really quick just so I can do the example. But it's so quick and so easy to make these edits that you can then, modify this really quickly in a couple of minutes and get exactly what your customer would need. Okay? That makes sense? I'm not going to go through and do the whole thing, but you could basically go in and scale the entire thing and just move all this to match exactly what you wanted to do. It's super easy to match that kind of stuff. Okay? This is a pretty extreme example. The difference between a size 7 and a size 11 is not that proportionally different. It would just be a matter of like scaling the thing and then pushing it back into the correct shape. This is like a really extreme example. All right, so we've offset this, right? We've offset this SubD, and we run 2 NURBS on that, and then we line these 2 up. And I would have done this. I would have done this in 1 step. I wouldn't have done this in 2 steps. I would have done the outside SubD, then I would have offset, done the inside SubD, converted them both to NURBS, and then done this, but I just wanted to show this is a little bit more of a crowd pleaser. So, oops, that's the SubD. So then what I can do is I can take the offset and I can Boolean it. This makes me giddy every time I do this. Ta-da, shelled part. Not only shelled part, but beautiful inside shell, right? A lot of times the inside shells on things, we get what we call bow ties or self-intersecting surfaces. And what happens is if we do something like this, imagine you've got a surface like this and you try and offset it. See that? See that cross right there? That's called a self-intersection. And in this case, what the surface would do is it would do this. And we don't want that, right? We don't want that. We don't want that inside offset to do that. The curve offsetter is smart enough to clip that off, but the surface offsetter isn't. And so if we surface offset this, in fact, we can even, I should be able to demo this. Let's see. If I extrude this and then I do an offset on this. Now I got to go farther. See that? See this bow tie? This is usually what happens when you offset a NURBS surface. SubDs don't do that. SubDs offset the vertex normals, and if they do bow tie, you just go through and untie it. It's super easy to do, so that you can end up with these really beautiful offsets for stuff like this. So now what we've done, let's go back here, and then let's take out this one. Is I have a beautiful offset, shelled, solid, NURBS part. It will pass show naked edges. It will pass check, boom, boom. It passes cell open polysurf. This thing is ready to go. I can print this, I can CNC it, I can turn it into a chocolate mold, I can do whatever I want, right? So this process of mesh, SubD, NURBS is included in 7. It's included with your upgrade price. It doesn't cost $30,000 to have a seat of GeoMagick. It allows you to be able to take this stuff and do what you want. Now, jewelers, I know there's some jewelers in the audience here. Before you start going, doing a victory lap around your studio, if I've got a ring, and you'll need to think about this as you're building your parts. This is 4 years of art school coming right at you. And let's do, if Travis Servio was watching me right now, he would be like, stop, stop, stop doing this. But let's do an array. All right, so this is my really, really awful ring. Let's say this was a scan. If I was to do this, what I would probably do is I would break this up into a couple of different pieces. I would scan this part, I would scan this part, and I would scan these pieces individually, if possible, right? Or I would make one scan and then I would mesh edit this stuff out, and then I would, because what I want to do is I want to be able to make this a SubD, this a SubD, and each one of these individual SubDs. And so what I would probably do is try to break my model up into pieces, either using ZBrush or using Rhino, and making what my business partner likes to refer to as a parts car. So you've got your whole, right? And then you've got the little bits and pieces. And ideally what I would want is for each one of these individual pieces to be a separate SubD, so that then I could modify them individually instead of having to try and get like one big crazy SubD. Now it'll work. Like if I grab this whole thing and I Boolean it together and I quad mesh it, this is another way to use this tool, by the way. I'm going to bounce this up a little bit. I'm going to do like 900 here, and I'm going to set my adaptive size to 50 because I want some more control. It will actually quad mesh this, which means I can take this and then to SubD it. And this is now my SubD model. So I can do all of the same edits I did before, right? I can take these and move them around, and they do that nice smooth edits. But depending on how much detail I wanted to have, this might not necessarily be the best way to do this. What I might want to do is, instead of this all in one shot, I might want to do, let's back up a bit. I might want to do this and then this separately. So I quad this, and let's go something really low. And then let's quad this. We use the same settings. And actually, that's probably too much. Let's do like 50 here. And let's do like 10 here. Because again, we want to have as little detail as we can, right? So now I've got these two quad meshes, and I'm going to SubD this. And I'm going to SubD this. Big rain. So now I've got two SubD parts in here, and I think I had creases on. I think that's why this got in here. So let's get rid of the crease. Where's my crease tool? There it is. All right, something wonky's going on there, but this is why we put out betas, so that you guys can test it and find all these problems for us. But this still gives me the ability to be able to modify this stuff smoothly, assuming that that was not janked up, and I don't know what that split is. I'll have to figure that out later. But this allows us to be able to make these modifications down here, and then we can then convert these to NURBS and then Boolean them together. Okay? Jewelers are all like, loser. All right, we're speaking in conceptual terms here. Go easy on me. All right, so that's one way to look at this. Instead of like cranking the whole thing into one big fat SubD, you might want to break it up into a couple little pieces. But in this case down here, this actually is a super successful way of doing this, where in the past you would have had to try and project curves and like draw surfaces and loft it and all that kind of stuff. And at the end, you'd still end up with a poly surface that would be difficult to deal with. Okay? Heath, how'd I do? Does that ring a solid or a shell? It would be a solid if I had done it correctly. The SubDs, by definition, if it comes from a solid object, it turns into a solid object. If it's an open object, it turns into an open object. Here's the cool thing about SubDs, though, is if they have holes in them, it's easy to fix. You can just go and build a new little mesh face in there and join it back in. Okay? And I'll do another webinar as we go farther into SubDs. I'll do like a how do you make something in SubDs webinar. But this is one. Heath brought this, and he so kindly allowed us to use this part, which I really appreciate. And so I thought this was a cool demo so that we could see how you go from here to here. All right. That's about all I've got for you today. I just wanted to show this and get this out there and let you start playing with it and see what you think. And if you run into problems along the way, hit the forum. If you hit our if you guys aren't on the forum, please get on the forum. Go up here to categories and go to Serengeti. Serengeti is where all things SubDs live. There is actually a SubD. I think there's a SubD. There might be a SubD subcategory, but if not, it's all, oh, yeah, it is actually. There's a SubD subcategory. So this is where all things SubDs live. So if you want to learn more about that, this is where all the discussion is happening. If you find something that's broken, let us know. If you find something that you think sucks, let us know. That's why we make our betas public. But that's pretty much what I have for you today. So, any other questions? Anything else you want to talk about? Any other scenarios? When is V7 launching? Again, that's you're trying to get me fired, but the best answer I can give you is soon. That's a McNeil soon. If you've been with us for a while, you know that soon can mean anything. So you're not going to catch me on tape telling you when a launch date is, unless you want to pay my rent. Even then, I wouldn't tell you. The best answer I can give you is it's available right now, which is with all of our betas. If you're a current license holder of V6, it's available right now, which means you can get it today. I, as a tester and as a tech person, have been using this for probably a year. And so most of my production stuff is being done in V7 now, and it's been really solid for me. That doesn't mean it'll be really solid for you because it is beta. So beware, make sure that you save often and save backups of the things that you do. If it's mission critical, don't scream at us if you do something that you have to get done and you were using beta software and it crashed. We warned you. All right, so save often. It is beta, it does change quite a bit. All right, any other questions? Anything else I can do for you today? This is, to the best of my knowledge, available on both the Mac and PC version of 7. So if you are a V6 Mac user, you can download the V7 Mac and do that as well. The $3,500 scanner I mentioned before, that is Next Engine. Next Engine makes this little desktop scanner, and this thing is actually pretty doggone good for what it is. I think, I don't know what the, yeah, $29.95 with a turntable. But wait, there's more. Can you explain some features of layouting in Rhino 6? Not in this webinar, but there are some, let's see. Here is a wiki page that is, here is a Rhino 6 layout. Mary Fouget, which her email is down here, is the point person on layouts. I don't use layouts very often in my own work, I got to be honest. Mary is an architect and a programmer by trade, so she's the one that has point on this. And then there's an intro to layouts tutorial here. There's support files, and then this is a version 5 one, but it's very slow when I have a lot of layouts and fails once in a while. Let Mary know, and she is the one, and here's a whole spiel on layouts. And if you have any issues with it, let her know, because Mary is the point person on layouts. So she would be the one that would need to know if you're having trouble with it. Is there another course next week, same time? The next one, in order to find these, if we go to this page right here, getting started live, this one right here. That should be it. This is where you can always find where they are. You can register for them here. Okay, so it's on, if we start at the beginning, it's at learn, it's buried. Learn, I think it's under live classes, Rhino live, and then register here. So this is where they're all going to be. The next one is Thursday, February 6th, and that is for Mac. And I probably, just a heads up, I'm probably going to cover this same material for the Mac folks. But since it's interactive, it may shift off into a different direction or not. But we do them about once a month. Pacific time, yeah, 9 a.m. PST. European getting started sessions, you'd have to check on the EU site. We do have an office in Barcelona, and I do believe they do some ones in different languages and things like that. But for the most part, I think this is it. So just to, if you don't want to stay up and watch this, we have a Vimeo page, which is here. And all of these get posted both on Vimeo and YouTube. So this is our Vimeo page. And then, let's see, I think I have the YouTube. This is our YouTube page. And these will all get posted here. This was the last one I did, this cycles PBR. We were talking about cycles, but Andreas, there was you had asked if there were some other ones that were posted that were easier. These are the ones that you'll want to look at. The getting started for Rhino. This is all the getting started ones. The water bottle is a really good one to get started with, and then maybe like the pan, corkscrew, things like that would be good to dig into as well. All right, any other questions? If not, I will let you run. Thank you for joining me. I appreciate it. People experiencing issues scanning diamonds and jewelry due to light reflection. Typically, they would be dusted with a powder so that they're opaque and then scanned. But yeah, you would have all sorts of trouble if you tried to scan a diamond with a white light scanner, because it would refract all over the place. Catherine, no difference between Vimeo and YouTube other than just personal preference. They're the same videos. All right, any other questions? If not, I'll let you go. Thank you very much for joining. I'm Kyle Houchins. This is Getting Started with Rhino 7. Woohoo, 7. And next month, we'll probably do something a little bit more traditional, do a traditional build in 6. So, all right. Hope you enjoyed it. Thanks for coming, and we will catch you next time. Thanks. Bye.